Today, I am going to explain about the Lexical Analyzer. It is a partial topic of the first lesson. Before getting into the Lexical Analyzer, we look into the phases of the compiler or structure of the compiler design. As here, we can observe a flowchart of a phase of the compiler, which contains the source program, and enters into the compilation process. After completing the compilation process, then the target program is generated, and every phase of compilation is dependent on symbol table manager and error handler. By this symbol table manager and error handler, every phase of the compilation can be done with the whole process and get into the target program. So, coming to the Lexical Analyzer. Firstly, we will discuss the token. What is a token? Lexical Analyzer reads each statement of the source code program line by line, and then it is broken into a sequence of units called tokens. In a general way, let us consider an expression as a equals b plus 10 as we have discussed earlier. It is broken into small units, that is a equals b plus 10. Here we are describing each unit inclusively. A is a letter or alphabet, equals is a equal symbol, b is a letter or alphabet, plus is addition symbol, 10 is a number like this way. So, the left part is called the value of the token and the right part is called the type of token that can be explained in detail. By this example we can say that token is classified into two types. They are type of tokens and value of tokens. The type of tokens are identifiers, variables, operators, keywords, contents, etc. Coming to the values of the token, name of a particular identifier or a particular variable and current variable or current position of variable, these all come under the token of the value of token. Let's have an example in technical. So, let's consider int c equals 10. It is broken into small units, so the left side part is the value of the token and the right side part here is int. It is a keyword and c is an identifier. Equals is an operator and 10 is a constant. A semicolon is a symbol called at the end of the statement. This is called the type of token. Into the keyword, identifier, operator, constant. Here we can see that identifier is an identity, that is a name of a particular object. Keyword is a word or phrase that describes the content. Constant is a fixed value. For example, in general, let us consider a basket of apples. So here identifier means name of the objects. So the name of the object is apple or basket of apples. And then, the keyword is nothing but, as we discussed, it is a word or phrase that describes the content here. An apple is red in color, and coming to the constant, it is a fixed value. Here, we have 7 apples in a basket. It's a general example. Examples for keywords, identifiers, operators, symbols are keywords, int, for, while, if, etc., identifiers, variable name, function name, etc. Operators, plus, minus, equals, multiplication and division. Other symbols, comma, semicolon, double quotes, etc. Now let's discuss lexical analysis. As we know, Lexical Analyzer is the first phase of the compilation process. It converts a sequence of characters into a sequence of tokens and removes the extra space or comments written in the source code. Let's consider an example. Here, we take int equals 20. This statement is broken down into the below format, where int is a keyword, a is an identifier, equals is a keyword, 20 is a constant, semicolon is a symbol. The programs that perform lexical analysis are called lexical analyzers or lexers. If lexical analyzers detect that a token is invalid, it generates errors. These errors can be handled by error handlers, and they are reported to the user and the user corrects it. In the lexical analyzer process, first it reads the character streams from the source code, and later checks whether tokens are valid or not, and then pass the data into the syntax analyzer. Now let's see the working diagram of Lexical Analyzer. We can observe two phases, Lexical Analyzer and Parser. As we know, a parser is nothing but a syntax tree. Here the Lexical Analyzer takes the source code as an input, and breaks it down into small units called tokens. And those tokens are sent into the syntax analyzer. Later the parser sends a next token command to the Lexical Analyzer. Now the Lexical Analyzer scans the source code again. If it finds the next token, it sends it back to the parser. Here both the Lexical Analyzer and the parser are dependent on the symbol table, where the symbol table contains each and every information about the identifiers, keywords, variables, array names, etc. Next, let's see the role of Lexical Analyzer. In the role of Lexical Analyzer, it also performs some tasks. There are 1. It reads input characters from the source program. As we discussed earlier. 2. It helps in identifying the tokens into the symbol table. 3. It removes white spaces and comments from the source program. Let's consider a hello world program. Here the Lexical Analyzer removes all the spaces in the code and converts it into the below format. 4. Correlates the error message with the source code. Let us consider the previous example. If we miss a semicolon at the end of one statement, we get an error, and this error is handled by the error handler and it sends the error to the user to correct it. Now let's consider Lexical Analyzer versus Parser. Parser is nothing but the syntax analyzer. These both are separated to simplify the design of a compiler. Let's consider an example. As we know, Lexical Analyzer has a separate design and Parser has a separate design. If these both designs are combined, then there will be a complexity in the designing process. To remove that complexity, we are considering these two as two different steps. They also increase the efficiency of the compiler. Let's see how. The Lexical Analyzer uses regular expressions, and those regular expressions are recognized by finite automata. Whereas Syntax Analyzer uses context-free grammar, which generates hierarchical structures or parse trees. These are recognized by the pushdown automata, which is more complex than the finite automata. Here, if both Lexical Analyzer and the parser uses the same kind of automata, then it may become complex and finally affects the efficiency of the compiler. And the next is to enhance the portability of the compiler. Portability means working on different platforms. As they both have different processes and functionalities, separating them will increase the portability of the compiler. Well, that's the end of today's topic. Along with the video explanations, we offer notes, mind maps, infographics and more to all the subjects from your syllabus. And also career guidance programs from current working IT professionals. And many more to our supporters. To join our supporters community, use the subscription link given below. For more topics from your syllabus, please visit our website given in the description. If you like the explanation, press the like button and rate us from 1 to 5 in the comments section below. For getting updates on any video we posted, please subscribe to our channel and press the bell icon. We will be back with another concept soon.